What's up, guys?
What's up?
Some snacks? Hi, we only got a couple more days. We got a lot to eat. Kind of start seeing what people really like.
My presentation.
Because people start targeting certain things, and you're like, man, I wouldn't eat that. But then by Thursday, like you're kind of relaxed. What's important? You're like, I'll still eat a Nutty Buddy or whatever. So your job was to do 1 through 25. So get out 1 through 25. I want to go over the actual answers to 1 through 25. And with those answers, then once you see the answers, we'll actually start showing you how to do these ones that you don't know how to do. And please, guys, I know a lot of times, especially early on when you start looking at these state tests, and there may be stuff we haven't even covered. Or there may be stuff that really is not fair to put on these tests that maybe we will cover. But if you really want to get better, which I hope you do, you with me? If you really want to get better, you really can. I had a girl a few years ago who, and it was one of my better comprehensive math teams I've ever had. It just happened to line up when I had my juniors and seniors, and I had these 4 guys that were probably top 6 math team performers in history. They were awesome. And she was really good. She always had the highest average in the class, but she was always 5th or 6th because at these tournaments, these other people were beating her. And she came up to me, she's like, I'm sick of getting beaten by these guys at these tournaments. What can I do to get better? I'm like, well, we're going to review and we're going to go over a few tests, but if you want to do a few extra ones, if you do them and actually learn from these keys, you'll get better. So she did. She went home and she did 2 or 3 practice exams on her own that we weren't doing. I gave her the solutions. She would come in there and ask me questions about the solutions and really learn how to do some extra stuff. She went in there and she came in 3rd in the state and only lost to like one of my monster 4 kids and then one other kid from, I don't know, Hoover or something like that. But ended up being really, well, maybe not Hoover, but somebody who was really, really good. But it made a difference, her really focusing on these tests and trying to learn from them. And after, we're going to do a bunch of them. You can see that from the sheet. If you're learning from them and asking questions, that's how you're going to really get better. And don't worry about the fact that you might have gone, man, I did all 25 and there were like 20 I couldn't do. And the 5 I did do, I missed 3 of them. Or maybe I missed all of them. That's okay. Just try to get better and try to learn and maybe expose some of these weaknesses. So with that being said, questions, I'll tell you what, let me go through one. I said 1 through 25, right? Not odds. Okay, so here's number 1. Number 1 is C. Number 2 is B. Number 3 is E. Number 4 is E. Number 5 is E. You can see that E is definitely an option. Number 6 is E. Number 7 is D. Number 8 is B. 9 is D. 10 is D. 11 is C. 12 is C. 13 is E. 14 is A. 15 is B. 16 is B. 17 is D. 18 is E. 19 is D. 20 is C. 21 is E. 22 is D. 23 is C. 24 is, I don't have a letter here, but the answer I think is 7. D is D. And 25, also I don't have an answer, but the answer was, I have an answer, it's 40. B. B. So you said,
what was 23?
23 is C. All right, and the way they score these, just for your information, is you get 5 points for being right. So if you are correct, you get +5. If you're incorrect, you get 0. Sorry, if you leave it blank, you get +1. And if you are incorrect, you get a 0. So it's really kind of like the same kind of scoring you'd see at Vestavia, where you get 4 for being correct, 0 for leaving it blank, and -1 for being incorrect. So all they did, so you still don't want to guess if you have no idea. There's no benefit in guessing, because if you think about it, if you blindly guess on 5 questions, you're probably going to get 1/5 of those. So you're going to get 1 right, which is +5, and you're going to have all the others incorrect to be 0. It'd be the same difference as leaving them blank and getting all 5 blank and getting +5. Now, if you can use your education, you're an educated guess. And I don't mean this. This is bad educated guessing. Man, it just looks wrong. Listen, they design the questions to look a certain way. They design the questions to suck you in. So literally, if you have no idea and you're just eyeballing it and picking one that looks a little sexy, guess what? You're probably falling into the pitfall they're designing for you. Don't do that. Literally, a better option would be to go, man, that one really looks good, so I'm not picking it. I mean, look if you have no idea. But if you can eliminate one option, like if you're looking at this and going, wait a minute, logically, there's no way this could be 0, and 0 is an option. And if I can eliminate that, and now I'm down to just 4 options to choose from, well, now the odds are in your favor, just strictly from a probability standpoint. So I usually guess when I can eliminate 1 or 2 things if I know that for certain, but I'm not talking about eliminating it because you just have a hunch. That's a good way to get a horrible score. And listen, I had a kid named Kern Williams once, and he made a 34 at Vestavia, which is a really good score. It was the highest grade in our class. And I was like, dude, awesome. He goes, Mr. Hurry, don't give me too much praise. I just went crazy and guessed on everything. I was like, I told you not to do that. He goes, man, you miss 100% of the shots you don't take. And I was like, okay. The next test, he shows up at Hoover, tries the same method. I think he had it was single digits, 4 or 6. And truly, he would have done much better than that, and maybe even helped our team because he was a pretty smart kid. Probably would have helped us had he just gone with what he knew. And yeah, maybe you don't get lucky, but if you go with what you know, I think that's probably your best bet. Okay, unless you know you can eliminate something, I would almost rather you not guess. Okay, so your scores here, if you just left the test blank, you're going to make a 50, right? 50 questions, all blank, 50. So a 50 is not a good score, right? It'd be great at the stadium, but not here. Here, a good score, if you can get over 100, that's positive. So like right here, if you count up the number you got right and you multiply it by 5, right? And then you take all the numbers you didn't guess on and you add 1 for those, and your score is at 50, then that's a good place to start. If your score is 100, that's a great place. Okay? The highest score last year, I think in Algebra 2 was maybe a 202, was Brandon in your grade. And he won the tournament. And we won the state, and our second best score was about a 135. Now, that varies from test to test. Sometimes the test A we go over might be a lot harder than the test C we go over in terms of high scores and stuff. But we'll talk about that later. All right, so random questions. I don't have the time to go over all 25 in class, and I'm going to give you this key tomorrow. After we go over the whole thing, I will hand you the solutions. And my hope is that you'll actually go through and look through these solutions and try to figure out maybe some stuff that we didn't get a chance to talk about. But in the meantime, do y'all have questions about any of these? I just want to talk about them.
I do.
And if it's super ugly, I might go, you know what? Why don't we just put a pin in it and we'll get back to it later. Yes?
I just don't understand what number 3 is saying. Like, it just says which of the following is correct ordering.
Okay, so it's a bunch of inequalities on number 3, right? So
never mind. I just glanced at it and I thought it was commas.
Oh, no, yeah. So what they're doing is if you didn't know how to do number 3, it's a good problem to look at. But number 3, it's giving you these 3 values, which I have no idea what the 10th root of 10 is, or the cube root of 2, or the 5th root of 3. I know that they're small values, but I don't know which one's bigger than which one. I don't. So here's the logic behind how to do these. And basically they're saying which one is the biggest, because they have them in increasing order in theory, right? Which one of these is true? The way to know this is either make all the bases the same or make all the powers the same. Okay, so if I could find a common power, like there's no question which one's the biggest, right? I know that that's bigger because if these are the same, then all I gotta do is look at that. And also, there's no question which one's bigger here, is it? Because if the bases are the same, then the highest power would tell you that. Well, assuming that the bases aren't like fractions or something like that. So let's take a look at this and say, can I find a common situation with these powers? So here's my key for number 3. Let's check it out. All right, so I took the numbers 10 to the 1/10, 2 to the 1/3, and 3 to the 1/5, and I tried to make them have as close to this common exponent as possible. And so I did that by finding a common denominator. And let me show you how I can do this. By finding a common denominator, which between 10 and 3 and 5 was 30, I rewrote them all as 30 over 30, 10 over 30, and 6 over 30, right? And then now what can I do with that 30? I can treat it like a 30th root. And by pulling the 30 out of each of these, that leaves me the 30th root of 10 cubed, the 30th root of 2 to the 10th, and the 30th root of 3 to the 6th. All powers that I know. So 10 to the 3rd is 1,000, 2 to the 10th because your powers quiz, 1024, 3 to the 6th because your power quiz, 729. And now I can look at these and see that the bases, which one's bigger? That one. And if that's bigger, then it's going to have to go to the right. And the next biggest one is this. So 10 to the 1/10 is going to have to go in the middle. And then the smallest one is that one. So the 3 to the 1/5 would have to go there. Yeah. Yeah. Number 2 says, how many real solutions? Now, there may be better ways to do this, but when I looked at this, I just started guessing and checking and revising. So when it said how many real solutions, what I did notice was on a problem like this, how many real solutions? On a problem like this, as I start plugging numbers in like 1 and 2 and 3 and 4, as the numbers gets bigger, they're not going to be equal, are they? And even if I plug in negative numbers, as the numbers get bigger, they're not going to be equal. So I started out with stuff like 0. Okay, so first thing I did was try 0 to the 0. You might think that 0 to the 0 might be an answer, but actually 0 to the 0 is undefined. I don't know if you knew that. But a lot of people say anytime you raise anything to a 0 power, you get 1. But 0 to the 0 is undefined. So I can't do that. But what about 1 to the 1st? Is 1 to the 1st equal to 1? Yeah, so there's one solution. What about -1 to the -1 power? Is that equal to -1? Yeah, so if 1 to the 1st equals 1 and -1 to the -1 power equals -1, I can try other values all day. And I played around with a little. I plugged a half in there, and I went, is half to the half? No, that's a square root of a half. That's not equal to a half. And I tried stuff like, 2 to the 2nd, is that 2? I tried a few values, and I just saw that it was going nowhere. So in a situation like that, and there are other techniques you could use that aren't algebra, which again, sometimes are a little unfair. But in this case, there only ended up being those 2 values because that 0 to the 0, and I made a comment about that on the key, I'll show you later, that's undefined. So even though you might think 0 to the 0 is 0, it's not. And I think that's what probably sucked a lot of people in to choosing. Anybody fix C? Maybe not? Okay. What else? So it says the largest number by which the expression n cubed minus n is divisible by for all positive integral values of n. So they're saying if there was some number n cubed minus n, what would be divisible? Well, this is another one that I kind of just started a process. Okay, so I thought, what is n cubed minus n? Right? So I thought, well, if n is 1, then what I'm dealing with is 0, right? If n cubed is 2, if n is 2, then I'm dealing with 8 minus 2 is 6. If n is 3, I'm dealing with 27 minus 3 is 24. So I just started writing these out, right, for different values of n and taking a look at them and talking about what they were divisible by. Now, as I'm looking at my results, 0, 6, 24, The question was, what is the largest number that they're going to be divisible by? Well, I started looking at these values, 6, 24, 60. As I'm factoring them, what do I see happening? They're all divisible by what? 2 and a 3, which is 6. And you see the 3 is not changing. More 2s are happening. An occasional 5 or a 7 will jump in there, but the 3 is that one constant. Now, is that a guarantee that that's going to happen forever? No. I probably checked a lot further than that. I just quit showing examples. But at some point, I was like, you know what? I started noticing the pattern right here. It was not introducing anything other than that 3, and the other common value was a single 2. So if they all had a 6 in there, I went with 6. And the question was, yeah, what is the largest number? And the highest value was 6. Maybe that's why I quit checking. Since your options were 2, 3, 4, 5, and 6, I figured, well, since my options were 2, 3, 4, 5, and 6, A, B, C, D, and E, I figured, why bother checking anymore? If I see 6 right here on all of them, I'm done checking. Because it's not going to be any, you're not going to suddenly see some other value pop up.
Didn't you also just do 2 cubed minus 2 is 6, and since that's only 2 times 3, it couldn't be anything. No, it couldn't be.
Well, I'm not 100% certain that it's 6, because what if I had one of these that didn't have a 2 in it later on?
Oh, I guess that's.
That makes sense? But hey, sometimes it's better to be lucky than good, right? What else? 11? Okay, so 11 said, okay, there's really, honestly, I mean, I can show you the key, but there's not going to be a lot of point in talking about this because we haven't done trig identities, right? And this problem is not a hard problem if you know how to do a trig identity. It's not an easy problem, by the way. But there's a trig identity that's called an alpha plus beta identity. And I have it on the key and I can show it to you. And if you want to talk more about it, I can show you. But it's a matter of recognizing that this identity is the sine of alpha minus beta. So you subtract the 2 angles. This is actually a really tough question, even if it was on my identities test, because now you have to take that and treat it like a half angle identity. So you have to know 2 different identities to be able to get this answer. It would not be an easy question. Rarely do they put trig problems even on this test. This was one of the very first ones they gave. And because of that, they had some trig on there. It was the first year these women that write these tests did this test. And since then, the last couple of years, they haven't even had a trig problem on there. So I normally don't even cover trig. I'll wait till after the state test. The only reason we covered it this year is they bumped the state test back to April. So, and again, April 10th. So in the morning. So if you want to talk trig identities, we can talk after school, but there's really probably no point in this because I don't see that problem being on there. And even if it is, it's a pretty tough problem considering how young you guys are in identities. That would be, to me, that would be one of the harder problems on my test, even having gone over it all. What else? Somebody else? Anybody? 14. How many different prime numbers are factors of n if this log expression is true? Okay, I kind of like this problem if I remember it. Hold on. So 14, you remember how to do these kind of log problems? We need to solve for n. What's the first thing we do? We've done problems like this. So we start exponentiating, right? Now, let's think about this. Some people quit on this because they go, I don't know the math of that. So I'm going to go 2 exponentiate, and that would cancel this 2 log 2 out, right? And that's going to give me 2 to the 11th, which you know is 2048. So I'm going to go ahead and make that 2048. Then what? I'm going to go 3. Uh-oh. 3 log 3 cancels. But now I have 3 to this, which I didn't learn my powers of 3 quite that high. Then what am I going to do? Exponentiate with a 5. Well, now I have 5 to that. I don't think my calculator literally can do that. I'm not sure my calculator can even do that. It probably can. But this would be a huge stretch. And then I'm going to do what? 7 to that. That's going to give me n equals 7 to a huge number. That's the key to this problem. Because the question is what? How many different prime numbers are factors of this? Well, what's the prime factorization of 7 to the blah?
Yeah,
7 to the blah. What's the only prime number then? 7. A lot of people quit because as soon as they see 3 to the 2048, they go, what the heck? How am I supposed to do this? Just remember the whole example I gave you about being a rat in a maze? Have I given you this example? I know I've given you assuming the position, right? Okay, so being a rat in a maze, if you're a rat and they throw you into a maze, you're not going to know where you're going. But there's cheese somewhere. You smell it, right? You don't just curl up into the fetal position and cry to mama, right? You start looking around and trying to find the cheese. And eventually, because rats are pretty smart rodents, they find it. They get there and they figure it out. Well, you guys, these problems are designed to haunt you. They are designed to bring you pain and suffering. But a lot of times, they're designed, actually, these tests are pretty fair, I think, the ones they make. They used to be horribly unfair. But also, they design these problems to try to make to see if you're just going to curl up in the fetal position or if you're going to trust the math you knew. You knew how to do this math. I think almost all of you. And if you didn't, you got a reminder. So trust the math and just assume that you know how to do it and don't just bail because it starts to look ugly. That's what they're trying to get you to do. If you just held off 7 to a big number, well, that's just a bunch of 7s. The only prime number that goes into that is a 7. And remember, 1's not prime. So the biggest prime number would be 7. What else? Oh, I'm sorry, they didn't say biggest. They said how many different. So 7. If you picked B2 because you thought 1 was a prime number, well, it's not. Lesson learned.
Why did I not know one of the parts?
I don't know. I honestly don't know. I think the definition of a prime is a number that's not divisible by any number other than 1 in itself. And you're being a little redundant with 1 and 1. But anyway, funny story about prime numbers. I had a friend of mine who was a graduate assistant coach at Vandy. I think he played quarterback at Alabama, and then he ended up being a graduate assistant, trying to get into coaching, but didn't work out. But anyway, he was working with the offensive lineman at Vandy. Okay. So he was up there and he was like, all right, guys, let's go. Let's hit the showers. They're like, hold up, coach. And these linemen were like huddled around. He's like, guys, we got to go. Come on. Got to clear the field. 1 second, coach. He was like, ah. So he got irritated. So he walks out there to him just in time to hear them. They're huddled around there. They're like, I'm telling you, man, 1 is not a prime number. That's offensive lineman at Vandy. I thought it was pretty funny. The idea. Anyway, what else we got? 18. The product of the roots. Okay, I liked 18. 18 was a bit of an algebra menace. Okay, and if you have never seen this, be patient, hold on. But I'm going to show you this. It's a little uglier than you probably want to see, but it's doable and it'll make a little sense, but it's not pretty. Okay, so number 18 says the product of the roots. Now, you may not know this, but if you have a polynomial, do you know how to find the product of the roots? Quick, polynomial meaning something like ax to the n plus bx to the n minus 1 plus cx to the n minus 2, yada, 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 yada. So something like 3x to the 4th plus 2x to the 3rd minus 5x squared plus 6x minus 7. Do you know how to find the product of all of the roots just like that? See, this is something we would have done in ciphering at the beginning of the year, but we didn't do that this year because of all the blue-red garbage. The product of the roots you can find by taking the constant and putting it over the lead coefficient. And if it's even, you're done. Highest power. If the highest power is odd, change the sign. Which means I have no idea what the 4 solutions are to that equation. I have no idea what they are. But if I multiply them together, I'm going to get negative 7/3. Coefficient over lead coefficient. It's a great thing to know. I think it shows up somewhere else on this test. It actually is not going to be used on this problem. Sum of the roots is this. Take the second highest coefficient, highest power, there's the highest power, there's the second highest power. Take that, this would be the sum of the roots, which is 2. Take the lead coefficient, which is 3, change the sign. Always the sum of the roots. I have no idea what they are, but if you add them together, negative 2/3. Change the sign of that over this, or take that over that, right? Always true. Now this one, if you look at 18, this is not a polynomial because it's not x squared x constant, it's x squared, and then you have an x squared on the bottom. So it kind of messes all that up. So I got to find a different approach to it. So how do I find the product of the roots? I actually am going to have to go solve this. Now, if I'm trying to find the product of the roots, let's make this an equation, which I normally don't do, but it said roots, so solutions. So I am going to, anybody got any ideas of how to solve something like this when you have an x squared in the bottom? So if I multiplied everything by an x squared, that would give me x to the 4th here, minus 4 root 7 x squared, and then plus a regular 28. Are y'all with me? Now, how could I solve that since well, if you can factor this, you're very clever. That's awesome. But if you don't see how to factor it, what do I have at my disposal to help me solve something like this?
Is it just like
Quadratic formula.
well,
But I wouldn't be solving for x. What would I be solving for?
x
X squared. So let's check it out.
X squared.
Quadratic formula says x squared equals negative the b value. It's going to be ugly, just trust it. Negative the b value, so 4 root 7, plus or minus the square root of b squared. What happens when I square that? I get 16, careful, 16 times 7, which is 102.
What is that, 112?
112, right. 112 minus 4 times the a value, which is 1, times the c value, which is 28. All of that divided by 2 times the a value. Now, what is 4 times 28?
112.
Also 112. So all of this goes away. So what appeared like was going to be awful ended up being pretty nice. And I end up with what? X squared is 2 root 7. Are you with me? Now the question was the product of all of the roots. Now the product, what can I do to find product? I got to find x first, right? So what are my x's here? So I got to square root that, and I get x equals plus or minus the square root of 2 root 7. So if those are my 2 roots, how do I find the product of them? Multiply them together. So I got to multiply a negative square root of 2 root 7 times a positive square root of 2 root 7. How do I multiply 2 radicals together? How do I multiply a radical times a radical? Don't I get 1 big radical? So what do I get? 1 big radical with what inside? 4 times 7, which is root 28. So what's the product end up giving me? So that's kind of ugly. Maybe you feel like that's a little bit beyond your pay grade, but I got news for you. I didn't solve that. I didn't learn any algebra beyond what you know that helped me with this. But I have one thing maybe you don't have yet, and that is I'm always very confident that my algebra is enough. I am. Now, your algebra wasn't enough on that trig problem. You haven't learned that. But like when I see a solve problem, I am pretty confident my algebra is enough, so I'm not afraid of it. I just try them, and I'm fairly competitive, and I don't like these problems to beat me. So I just continue to look at them until I figure them out. But that's me just going, wait a minute, I know how to solve something that looks quadratic-ish. Let's use the quadratic formula. What else you got? Anybody get that?
I guess.
Uh,
Maybe 20.
20? 20 says find the sum of all distinct 3-digit numbers that contain only 1, 2, 3, and 4, each at most once. Now, there is a clever way to do this, but it requires some probability and some thinking that I haven't gone over. So I just wrote them all out and started noticing some patterns. So let me just show you my thinking on this. So I just started thinking like this. Okay, what would happen if I had ones here? If I had ones right there, then I could have 2, 3, or 2, 4. I'm just writing out every combination. I could have 3, 2, or 3, 4. Or I could have 4, 2, or 4, 3. Those are my only other options if there's a 1 right there, right? And I added that together and I got 798. Okay? And then I looked at this and I said, what if I have 2s right there? All right, then I could have 1, 3, or 1, 4, 3, 1, or 3, 4, 4, 1, or 4, 3. I wrote out all the combinations, other combinations. And I added that up. And I did this all this way. And when I did this, I ended up with 66, 60. And that's every possible option. I could have nothing but 1s, nothing but 2s, nothing but 3s, nothing but 4s. That's every possible option. Now, I could also say, and if you really think about this, it makes sense. When I'm adding all these up, let me back up on this. Hold on. Oh, okay. You could also say that I could have 6 options for 4 in that column, 6 options for 3 in that column, 6 options for 2, 6 options for 1. But if you really start thinking about it, look, the 6 1s in this first column, there's also 2, 4, 6 1s in the second column. There's also 2, 4, 6 1s in the third column. So 1s are going to always show up 6 times in each column. 2s are going to show up either 6 times in the first, 6 times in the second, or 6 times in the third. I just started noticing those patterns. Every number shows up 6 times in each column. So if every number shows up 6 times in each column, I'm going to have basically 24, 18, 12, and 6. I'm going to get 60 in each column, which means I'm going to have 60 100s, 60 10s, and 60 1s. That's another way to think about it without writing everything out. But that was me logically thinking through it. This was me just writing out every example. And a lot of times for you guys, if you're one that normally does really well on tests, and like if you're like one of those that's like, oh yeah, I'm always in the top 4, or 5, or 10 of Homer's class. If that's you, then maybe you don't want to spend 5 or 10 minutes on one problem because you might be better served doing other stuff that you know how to do more quickly. And then maybe coming back to something like this. But I know that you guys can write out every option, right? If you just take the time and just systematically do it, you can write out every option and add it together. It might be a lot of time spent on one problem, but that's okay. But something like this, I might have gone, if I didn't have a plan immediately, I'd probably put a star by it, come back to it and look at it. It's one of those things like when I have time, I know I can do it, just matter how much time I'm willing to spend on it. Not that this took me that much time, but other problems might be solved more quickly. What else? It does. And again, I don't even teach the triple angle cosine identity until pre-cal. And most pre-cal classes don't even do triple or sines or cosines. But that is the triple angle identity. And again, it's not an easy question. But once you learn your identity, it's not bad. Like they told you, if you know that identity and they tell you the cosine of an angle is 4/5, you can just plug the 4/5 in for the cosine theta and simplify the math. So we don't even teach that. So a lot of people only learn triple angle identities, which means you'd have to convert the cosine to a sine, then use the sine value in there. But anyway, I threw it up there. But you'll see as we move through these state tests, you're going to see less and less trig. And I don't even feel bad about it because even the trig that does show up, most people, it's beyond their pay grade in Algebra 2. I'm pretty sure we learn triple angle sine eventually, but I don't even think we learn triple angle cosine. Maybe we do. 23. Okay. Now, logarithms, for some reason, strike fear into the heart of many a math team person. But they're really, surprisingly, I love the logarithms because there's only a certain number of rules. And I think a lot of you that struggle with logs this year, when we go back through them next year, which we don't learn anything new, when you go back through them a second time, it's like anything. The second time through, it feels like you don't have blinders on. It kind of the world opens up a little bit. You feel a little bit better about it. Especially if you're in a regular pre-calc, you'll really feel better about it. But one thing you did learn about logs is this. To add a log to another log, what do I do? If they have the same base. It was like this in your book or in your notes. Say I have log base x of A plus log base x of B. What did you learn? You can combine it into one log by multiplying those two things. And if it was a minus, what would you do? Divide A over B. Well, it's a plus. So all of these, I'm adding the all logs together. So I can combine all of this into one log base 10 by doing what? Multiplying them. So I'm going to multiply a half times 2/3 times 3/4 times what? You know what's coming next? 4/5, and then next 5/6, and then I'm going to keep doing this all the way through 98 99ths and 99 100ths. I particularly don't feel like writing all those out. Now, what happens when you do this? You can see that and that and that cancels, and with a little projection, what do you see? Everything else is going to cancel except the what? The 100 on the bottom, which leaves you log base 10 of 1 over 100. Now, if you got to there, great, but you didn't get the answer if you stopped there. How can I simplify that? Okay, that's 10 squared on the bottom, which is 10 to the negative 2 power. And what did you learn? If these two bases are the same, then everything cancels and you're left with negative 2. So it's really not, it's just a couple little log rules you got to remember. Nothing overly special. But anyway. I kind of like the girls that write this. They're pretty smart. They don't try to kill you like Vestavia does. Most of their problems are very doable. Sometimes they're ugly. The algebra is, but it is a math state tournament. Also, this little notation, when I first saw it, I'm like, I don't even know what that means. This is a bad font. They're using a bad font on their, or they don't have a good equation editor to make these calculations. This means the first slope squared plus the second slope squared. So this is like first slope, second slope. All right. So M1 and M2, they should have written it like this. I thought it was some kind of combination notation or something when I first saw it. But that's what that means, if that was confusing to you. Yeah. Okay, so says for exactly 2 values of M. Oh, yeah. I remember this too. The line y equals that intersects the parabola at exactly 1 point. Now, if that intersects that at exactly 1 point, then I need to find an intersection. How do I find the intersection of a graph, a line, and a curve? How do you find an intersection if you have 2 equations? How do you solve? Do what? A system? So I'd have to solve one for one variable, plug it in. Everybody with me? Everybody, even people sleeping? Oh, you with me, man? We're Sugar Haven in here. How do you?
Come on, guys.
Come on, get some sugar in you. You should be like grandma's house. Like when they go over there and the grandma sneaks you all the sugar and makes you miserable for their parents the rest of the day. I have that privilege. You can be all hyper in 5th period. Like, what's wrong with you? Get out of my hand. Okay, guys, if I have a line and a curve, solve the system. That's going to be a little tricky because I'm going to plug that in there. So let's check it out. If I plug that in for y, I get mx plus 3 equal x squared plus 2x plus 7. Now I can subtract the 3 over, which gives me a 4, and I can subtract the mx over. Now here's where you got to be a little clever. It says I have one solution. Now think for a second. This is where not assuming the position. What do you know about one solution when you have a quadratic? Think. How can a quadratic only have one solution?
One's imaginary.
No, because imaginary always come in pairs. How can you have one solution? If it's a double root. Okay. If it's a double root, what does that mean about the way this factors?
It's a perfect square.
It's a perfect square trinomial. If it's a perfect square, see, this is me. I'm a rat in a maze, right? I don't know what the answer is. I'm just using what I know to navigate this problem. So if it's a double root, which means it's a perfect square trinomial, which means it factors in the same thing, what would this, the x term, have to be a perfect square, to factor perfectly? This would have to be what? X squared? It ends in a 4. What is this going to have to be? 4 or negative 4, maybe. Isn't that the only way it can factor? Because if there's a 4 there, it's got to factor as either plus or minus. That's my only option, right? Either plus 2 squared or minus 2 squared. So what that means is, what would m have to be for this to be positive 4?
-2 or 6.
Negative 2 or 6. Does that make sense? Because to make it positive 4, m would have to be negative 2, right? 2 minus a negative 2. To make it negative that, m would have to be regular 6. So those are my two values of m. What did the problem ask me to do? Square them both and add them together? Well, I don't know why they asked you to do that, but they said square them both and add them together. So if I square the negative 2, and if I square the 6 and add them together. Now, I'm not saying that's easy. I'm not. And hopefully through time, you'll start thinking a little bit more creatively like that. But guys, again, did I do any algebra here that you didn't actually know? Right? Some of you might go, yeah, I totally forgot about double roots, whatever. Okay, great, lesson learned, right? But again, if you remember the double root thing and you remember the perfect square thing, those are the connections. You just have to trust that your math is enough, trust that you've learned enough, and just start chalking them up to, I've learned something new or whatever. I really like that problem. That's kind of cool. What else? You can also use calculus to do that, but it's a little above your pay grade at this point. But you'll like calculus. It's most people who struggle, like I got people who made C's in my class 2 years ago. They're back in my AP Cal class, 97 average. I think it's easier in this class. For what it's worth. If you do your work. If you don't do your work, it's hit or miss.
Class next year is easier than this.
No, AP Calculus. I think AP Calculus is AAB is easier to do well, I think, than this class or my pre-AP, pre-Cal class.
What about next year compared to this class?
Next year compared to this class, I would say that this next year's a little bit harder, probably, but there's so much, I say that, but the grades don't seem to be overly different because I think people, first of all, you're a 10th grader. This is, for some of you, it's the first class you've really had to do something in. First class that's really pushed you to become a better student. You're going to figure that out as you take more and more AP classes. Like AP US History is a great rite of passage for you guys. If you're taking that, this class, you start growing up, so it doesn't feel as daunting. And some of you had algebra holes you're starting to fill in. Like I got a kid in my senior class who walked into my AP calculus class, was making C's, low B's, C's, maybe an occasional D. Now he's making solid A's on every test because he's figured out his weaknesses. He's worked to do that, but some people start growing up as they grow up as a student, not as a person, but as a student, they become more disciplined. They do their homework. They check and correct their work. Some of y'all, I don't know, started off rough, continue to be rough this year. Some of y'all made improvements. But as you learn to be a better student, I think my pre-cal class is not as big a deal. And you learn a lot of it. You've already learned it. Like you've already learned logs, you've already learned conics, you've already learned probability. All those things we've already done. Trig, you've already learned almost all the trig. A lot of it's just a repeat of what we did this year. Yeah, and I don't know that we do, well, we do one thing different in matrices, but we do it in a different section. It's called Gaussian elimination. But other than that, it's very similar. So a lot of it's a repeat. Some of it's new. What do we got? 4 or 5 minutes? Anybody else? Anybody? Okay, now I'm looking at a lot of your desks, and I saw empty desks or what looked like that you hadn't really done anything. I don't always, a lot of times I just come in here and ask questions. I want to see, if I come in here and say, all right, guys, I want you to turn in what you have. I don't want A, D, F, C. I want to see number 1, C, and your work. Number 2, blah, blah, blah. If you don't know how to do something, leave it blank. But if I ask you to take it up and all I see is a bunch of ACBB, I don't care. I don't want you to guess. So just writing down letters means nothing to me. I want to see your work and your process and try to do it legibly. So every now and then over the next couple weeks, I'm going to spot check your work. And don't feel bad if you honestly give it your best shot and you can only do 2 or 3 or 5 or 7 or 10 or whatever. All right. So next assignment, we're doing what?
25 or 26.
Yeah, and guys, this, I've tried to break it up a little bit, and but we've got, this week, and then we come back, we got a week of it, and then that very last week, I'm only going to do it 3 days, a week before the test, because I have to get in the other material. So I'm going to stop 3 days short, just kind of take a break and detour. But guys, try to give it your best on this, and when I do spot checks, make sure you've done the work, all right? So tomorrow, 26 through 50. Yes. Oh, and then lastly, make sure on that Friday, I know everybody thinks that the spring break starts Thursday at 3:10, but remember, Friday is technically a school day. Sometime between that Friday night and the day we come back, I need you to do that state test B, the evens, okay? If there's ever a day I'm going to take something up, it'll be that Monday coming back from spring break, all right? All right.
Are we gonna have like a meet on that day? Because we're gonna get to meet, like, or do we have to?
No. I designed it where you're free from me. But yeah, you can be just working on those things over the break. Does anybody have a test to make up in here? I don't think you do.
That's really good.
We don't have time. They're in there.
It's like a first period.
I just want to like look at that and stuff.
Yeah, remind me tomorrow we can do it.
Alright.
I kind of forgot about that actually.
Yeah.
Y'all feel free to grab a snack.
So,
Snack for the road.
yeah, like
Science.
it's like, yeah, it's really easy. Like I finished, like it's like 20 minutes.
Were they hard? All I know, there's only like 5.
No, running out.
It might not last till the rest of the time. It really can't. Yeah, really good. And if it's not grounded.
Yeah, the whole.
It's not.
All right, for those of you that always wonder, when am I ever going to use math? Let me just give you an example of why math matters.
Yeah.
Way too much.
Okay, everybody check this out. Check it out, guys. 1/3 of a cookie, 190 calories. A whole cookie, 420.
Wow. That's useful math.
That's bad math
Dang, Sam.
on a product that got printed and sent all over the world. Why math matters.
Wait, that.
I know.
Interesting.
Thank you, Mr. Murray.
Yeah. See you guys.
If I was just going about this problem.
Um, I would do what you're doing here. You could solve this for x and plug it in there if you wanted to. It's going to be a little ugly. Or you could,
Yeah, I tried that.
right here, this is 3 to the negative 2x. So if I raise this to the negative 1/2 power, I'd get 3 to the x equals 7 to the negative 1/2. Does that make sense?
Oh.
And then I could think about this as, so if I did solve, I'm not sure I did this. So this is 3 to the negative 2x equals 7. So if I raised it to the negative 1/2 power, I'd get 7 to the negative 1/2, right? Right, and then your 3 to the 6x plus 3, isn't that this,
Oh.
which is this? And I could plug that in.
Okay. Thank you.
Yeah. So